Okay, now this is the second session of analytical geometry. We'll be having those questions. The first one, when the two lines perpendicular, it is the relation of their gradients, product of their gradients make -1. So we will just find that unknown over there, writing equations. You can check through the memo. But the second question, I want to spend a bit more time. There is 6 marks. What do we do? Basically, we need to find the gradient of two lines intersecting. So what are the two lines? We must find gradient RP, and then this will give me the first angle of inclination. And then the other line, which angle is between, is RQ. So we need to find gradient RQ, which is same as, by the way, Rn. So gradient Rn will be enough. So then that will give me another angle of inclination. Okay. Now, remember, the first one is basically just tan inverse the gradient, let's say M1. But the second one, because it's a decreasing line, tan inverse, I am going to add, let's say, I am going to add 180 degrees. So I'll get these two gradients. So the first angle of inclinations, I mean, after that. So with this angle of inclinations, the angle I am looking for, which is theta, is basically the difference of those angles. So we can just say alpha 2 minus alpha 1 will give me the answer. So you're going to find those things, and finally, as a third step, we will find their differences. Now, the angle of where is the angle of inclination of RP, for example? If they ask such a question, then don't worry about it. You can just extend the y-axis and see our RB. If you extend the line, so it will be somewhere there. You see, we don't really need that, but that's my angle of inclination. So that's alpha 1 or RP. Yeah, that's my alpha 1. That's that angle. And what about the other angle? If I extend the other line, see, they don't have x-intercepts. That's why it doesn't look they have, or we may just confuse where are those angles, but we don't really need to. And the other angle is going to be there. That's, we added 180, remember? So that's my alpha 2. So that's my alpha 1, and that's my alpha 2. Okay, but when we find their difference, actually, what do we get? We get the angle inside. Sorry. So this angle is alpha 2 minus alpha 1. So basically, the angle I have to find, it was good to look now. You see, the angle I need to find is what? How can I get the value of theta? So it is 180 minus their difference. 180 minus alpha 2 minus alpha 1. Okay, just to make sure, is it because it's sometimes straight their difference, but their difference gives me the other side of that straight line. Okay, it gives me that angle. So as you see, angles in a triangle, 2 interior is exterior angle rule. So from alpha 2, when you subtract alpha 1, you get that angle, but the angle they ask is the one inside. And it is not an obtuse angle, it's an acute angle. Or that could be the way, when you get their difference, for example, you get like 120 degrees as an answer. And it cannot be theta what they are asking. Look at theta, it's an acute angle. How can it be 120, whatever it is, or 130, or 140, or 110? You must say, oh, it must be the other side, because between two lines, there are two possible angles. And one of them can be acute, the other is obtuse at the same time. So that's why whatever that answer, the difference is, we subtract it from 180 to get our answer for theta. That's for 6 months. Okay, that method is for 6 months. Equation of a straight line, yes.
So sometimes they don't draw the thing to scale, sir.
Yeah, that's why you better connect those lines and to make sure. That's why I draw. You see, when you draw, actually the difference gives me angle, let's say R2, this part of R, not the other part. You can say R1, R2. It gives me the other part of theta. That's true. So it's not true. It's not drawn to scale. So it may be not correct. Just checking the angle looks small, acute, whatever. Now, equation of line Pn, that's fine. We have 2 points. You can get gradient and everything. All is good. And what about 1, 2, 3? Coordinates of L. It is midpoint. Do we know Q? Q are vertices of the triangle. We don't know Q. So how can we get the coordinates of L? See, it could be, we know N, that's fine, and we don't know Q. Sorry, we don't know Q, yes. And now they ask L. So how can we get
So
L
can we use midpoint?
without knowing
Yeah.
Q? Midpoint theorem can help
Like
because
PN parallel to LN.
because yes, the parallel line LN is parallel to PR. So those lines will be parallel when we draw that. Okay, let me draw that red line from N to L. So that line will be parallel to here because of midpoint theorem. So, but still, do I need to get a line equation or n is coordinate of n is given? I can get n. Oh no, I know n. Oh, I actually got. I can get q actually. That's not a problem because I know r. Remember? So r is -6 and 3. So what I will do is just work backward from there. From -6, let's do that way. I will write down. So what is r? R is -6 and 3. And I know a midpoint. What is midpoint? There is n as a midpoint, -1 and 2. So midpoint of then that will give me the q, isn't it? So I can just do these backward steps. So I can get q and then L. So don't worry about finding equation of line or whatever. So what happened is x coordinate increased by 5. So remember, I'll increase it one more 5. So then the x coordinate will become -1 plus 5. And what about y coordinate? Y coordinate is from 3 to 2, decreased by 1. It's going to decrease by another 1. Okay, so let's write the answer then. So it is -1 plus 5, it's 4. And then 2 minus 1, 4 and 1. Okay, that's the coordinates of Q. So after coordinates of Q, N shouldn't be a problem. L shouldn't be a problem. But midpoint rule is a good idea to remember here, even though it's not helping. So what is the coordinates of L then? -2 and 4, which is 2 over 2, which is 1. 5 and 1 gives you 6 over 2 is 1 and 3. You see, you got the answer that's for 5 marks. You got 1 and 3. But you have to find Q first and then L. That's for 5 marks, good. And then what else we have? Coordinates of A, if RL cuts Pn, it's N. Do we know of Pn? Okay, we got equation of Pn. And do we know equation of RL? We don't know, but we can. So, okay, it's just equating those two equations. No, we have equation of Pn. We already have, imagine. And then we can get equation of RL. Oh, by the way, I think that's why it is not more marks, because RL is a special line. What kind of a line is it? It's a horizontal line. You see the y coordinates, both y coordinates are 3, -6 and 3, and 1 and 3. So when you get it, this line equation is y is equal to 3. So what we are going to do is coordinates of the point they intersect. A is a point here. So what I know is y coordinate of A is 3 because it's already on that line. That's all. And how can I find x coordinate? You just substitute 3 into 1 to 1. Okay, so basically to find x, substitute y is equal to 3 into equation 1.2.2. That's it. So that will give you x, so that will give your answer. So what is important here? Actually, you can equate two lines, two equations, but we don't really need to spend a time finding equation of RL because it's a horizontal line. So that's y is equal to 3. Okay, so that was this line geometry question. This circle question, what can we say? Is there anything special? Coordinates of C, you know, we know the circle equation given. Remember, working backward quick is just like what? X minus half of the x coordinate, x coefficient, which is -3, half of -6 squared, and then plus y and half of the y coefficient minus half of -4 is -2. And then there is 12, but don't forget we must add square of -3, and then we must add square of -2. So that's how we are adding So the square of minus 3 and square of minus 2, we added. 3 was already there. So that's the circle equation. What's the circle equation then? Circle equation is x minus 3 square and then y minus 2 square is equal to 25. So that gives me the coordinates of C is what? 3 and 2. That's it. 5 marks. Coordinates of A, it's basically y-intercept of the circle. And how do you find y-intercept? You substitute x with 0. That's it. By the way, we will get two answers because it has two y-intercepts. Remember, you can see from the diagram, there are two y-intercepts. Obviously, we choose the positive one, the one above, that's A. Equation of BA. So how can we get equation of BA? It's a tangent line, it's perpendicular to AC. So I can find the gradient from AC, and I already know A, that wouldn't be a problem. And even the angle shouldn't be a big problem. But be careful, if they ask an angle approaching on y-axis, how can, let me just draw that shape, that part may be a bit different. Let's draw that. For example, we ask to find an equation or an angle at y-axis, like how can we get this angle here, like beta. So what do we do is, that's my x coordinate, I can get alpha. So first of all, I need to get gradient, remember? And what is alpha is tangent inverse of the gradient. So then after alpha, you know that's perpendicular. In this case, beta is to interior exterior. So it's going to be 90 plus alpha. So whatever my angle of inclination of the line, I will increase it by 90 to get what we need if there is such a situation. Okay. Now that was the question, similar question. Let's go through. Okay, let's look this question. It may be a little bit different. The question is asking length of radius and the circle equation for 1 mark each. So we are given a circle and the center is given x-intercepts, y-intercept. There's only one y-intercept, that's good, and there's a tangent line. So now if you look at the question asking radius only for 1 mark, so what could be, or why is it only 1 mark, is because if a circle touches x or y axis once, so if the x or y axis is a tangent line, so the distance, one of the absolute value of one of the coordinates actually become the radius. So basically, if I write the coordinates of, if I look at the coordinates of M, what do we see? X coordinate is 5, and then y coordinate is 4. 5 and 4. So that's why that length is basically 5, which is my radius, that's all. So this length down here is not radius, that length is 4. So it doesn't matter it is in the first or the second or the fourth or the third quadrant, doesn't really matter. It can be -5 the coordinate, but the radius is always positive, you know, you can just be careful. And when does it happen? It happens when it's tangent to one of the axes. So you just say it is 5. And after then, writing equation wouldn't be a problem. You can say x minus 5 square, and then y minus 4 square is square of r, which is 25. All right. Coordinates of A. What do you say for coordinates of A? Now, for coordinates of A, I just want you to maybe approach in this way. If we can draw that line, we can even use Pythagoras theorem. We don't really need to find, we can find x-intercept, you know, substitute y with 0, you get 2 possible answers. But rather than that, I may be suggesting this. So this length is 5, and that length is 4. So then using Pythagoras theorem, I can tell you this length will be 3. So that's why coordinates of A is 3 less than 5, and coordinates of B is 3 more than 5. So I can just say coordinates, x coordinate is 5 minus 3 and 0. And then what about B? It is 5 plus 3 and 0. So that's how I got my coordinates of A and B. So it is 2 and 0, and the other one B is 8 and 0. That's it. So you can apply Pythagoras theorem and do that. Or just find what? X-intercepts. And how do you find x-intercept? Substitute y with 0. I have the circle equation. Doesn't matter. Okay. Now, coordinates of B is given. Oh yeah, we already got it is 8 and 0. So gradient AB, tangent line, they are kind of easy. I skip them now. Let's say, write down the tangent SKL. Okay. Now, for SKL, do we know L or do we know S? Is it a parallel line? Yeah, you see that. So yeah, that's why I just go up and see what is that. It says SKL is parallel to x-axis. So that's a horizontal line. So remember, every circle has two horizontal tangents and two vertical tangents. How it works? For example, when you have a circle, you can always have two horizontal tangents, like the red ones, and then two vertical tangents, like the blue ones. And now, if you know the circle equation and the center and everything, that wouldn't be a problem. Like if I know center is, for example, 2 and 3, and the radius is, for example, what? Let's say 4. So what are my equations? So x will be 2 less than, so it's minus 2, 4 less than 2, and 4 more than 2. And what are the y coordinates? It's 4 less than 3, and 4 more than 3. So those are, it's 7, sorry. Those are my two horizontal and two vertical lines. How do I just get those things so quick? Because it's just adding or subtracting 4, as we know the radius. So now in this case, I know the center, and then I know it's the horizontal line tangent on the above. So I can actually write the coordinates of k just like that. So what's the coordinates of k? X coordinate is same as m, which is 5, and the y coordinate 4 will be increased by 5, so it is 9. And that's why this equation is y is equal to 9. And that's why coordinates of S is 0 and 9. So I can just write those things. And coordinates of L, okay, I don't know at the moment, but it is X and 9. I know the Y coordinate. So because every point on that line is Y coordinate has 9. Okay, so now that was something different. So I just mentioned on it. Now what else? So equation of SKL, okay, let's write it there as well. We got the answer as y is equal to 9. And then the next question says now, coordinates of L is 20 and 9. So how can I get that 20? We can use any Pythagoras theorem, any relation for x. Do we know any line equation? Yeah, you see, we know the line equation PB. So we already know that line equation. So it's just we are going to substitute y with 9 to get x coordinate. Okay, substitute into equation PB. So when you substitute into equation PB, which you already got, when you substitute y with 0, you are going to get x is 20. Okay, that's fine. That's fine. The length of ML, distance formula. We know M, we know L. That's not a problem as well. Okay, last question. Area of quadrilateral. Just look at that. That looks different. That's why actually we are looking now at this question. Quadrilateral ALKMB. So area of that quadrilateral. Remember, we already got the distance KL. Okay, distance ML. Sorry, that's in the previous question. But now, how we can even determine the area of this quadrilateral? So let me just think. Basically, the triangles here, MKL or MBL, they are congruent triangles. They are exactly the same triangles. And since we know those lines are perpendicular, okay, there will be kind of an easy way to find this triangle. Like for 5 marks, I know they have the same area. And then let me just draw that shape here. So there is this triangle and there is that one. And I know these triangles are exactly identical. Why? Okay, because this radius is 5 and that radius is 5. And that's 90 degrees. Sorry, and that's 90 degrees. And do we know the length KL? Yes, actually that is 15. Why? I mean, look at the corners. It is 5 and 9, and that is 20 and 9. So that's 15. So then I can tell you because of that, because of that 15, this must be 15. I don't really need to, but anyway, so I can actually find that area, this area. What is that area? Because those are the identical triangles, so they will have the same area. So then I can just multiply that area by 2 for the quadrilateral area. So what can we say? KML is congruent to BML. BML, these are congruent triangles. So by side angle side, maybe. So then what is area? Area of KML is what? 1/2 times 5 times 15. And so that's why, what is the area of quadrilateral? KMBL. So area of KMBL is basically 2 times 1/2 times 5 times 15. So 2 and 1/2 cancels. The answer is 75 square units. Okay, that will be finding area of the shape we have there, the quadrilateral LKMB. Okay, you can basically just find one of the areas of those triangles and times by 2. And the good thing is we know that 5 and this 15. So that's enough, quite enough, and necessary information that we can have those answers and we can get the answer for the area of a big shape. Okay, now this question, nothing seriously different. We can skip that. What about that one? Anything special? Let's have a look. We are given the angle ABC. So this angle is given. So that looks maybe a bit different question. So if we are given angle at B, how does it help me? So we know A, okay, we know B. What's the first question? Gradient AB. So that shouldn't be a problem, but the gradient BC will be -1, it says. So how can we get gradient BC? See, gradient of a line, let's mention there again, here again, the gradient of a line can have different ways to determine. So when we have gradient, you can always think about we have 2 points or not. So we have a parallel line or not, or we have a perpendicular line or not, or finally, what is that? We have angle of inclination or not. Now, in this case, according to BC, we have nothing. There's no 2 points, no parallel, no but angle of inclination could work. And see, those are the ones we may not have, we may not get help, but angle of inclination can be determined. That's why it must be given, must have given. So we're gonna find gradient of BC, and after gradient BC, we can find angle of inclination of BC, sorry, AB. So where is the angle of inclination of AB? Is this angle here at D, and then I can get angle of inclination of BC. So I need to get that alpha so that I can find the gradient, because the answer is what? The answer will be gradient BC is basically tangent alpha. Or if the answer is -1, I can tell you that angle must be 135, because that will give me -1. See, like I didn't solve it yet, but that angle must be 135 so that I can get the answer they want. I just know it. Okay, but how can I get alpha? So I know 73 was given, so I'll use that 73.1. So then I'll use that angle D. So basically, let's just say beta over there for D. So we must do what? We must say, let's say this is my beta, and that's 73.1. Yes. So firstly, I need to get beta. Beta is what? Tangent inverse gradient AB, which I already got in the previous step. And alpha is what? 2 interior is exterior. Alpha is whatever my answer for angle of inclination of AB plus 73.1. Okay, that will be my alpha. And after I got, and that must be, by the way, 135. Okay, then find the coordinates of C. Okay, that won't be a problem. That's just, we already know the gradient. I know this x coordinate is 0. I can find the equation, or I can say it is x and 0. So somehow coordinates of C wouldn't be a problem to get it. But 2.2, just be careful how it is done in that case. All right, this question, there's a trapezium shape is given. Let's have a look. Lines parallel, coordinates, and that angle is alpha. So anything, let's just read through. Gradient of AD. Gradient of AD is this line. Okay, we can just get it. Equation of BC. Yes, we now see as long as there is a point, that's enough because there are parallel lines. So I can use the same gradient I got in 3.1. And then value of Q, value of P if Q is 3. So you just substitute Y with 3. So you must get the value of P. That's fine. So these are only two marks, you see. Length of DF. So length of DF, I know D, I need to find F. And you see where is F? F is on x-axis. So since we already got equation of BC, so it's just x-intercept will give me coordinates of F. Then it is distance formula. So then that is fine. And show that the angle is 48.37. So to get angle, it's like the other question when we have two lines, we can get angle of inclination and angle of inclination, and their difference will give me the answer, remember. So same story. So we already have that gradient, find angle of inclination, find this gradient. We have 2 points, that's easy. So their difference will be the answer. But last question, the area, DCF. Now, how can I get the area of DCF? So assuming the coordinates of F, so let's find the coordinates of F first, because that will help me. Anything else we know, length of DF, the angle maybe 90, no, it doesn't need to be. So let's just see what is the coordinates of F, and then we can figure out the coordinates of C. Okay, so what's the coordinates of F? Do I need so I need to solve all the others quick so that I can get that condition. So what was the first one? Gradient AD. Gradient will be 7 minus 3, 7 plus 3 over 1 plus 4. So it is 2. And then the equation will be y plus 8 is equal to 2 times x plus 2. So then y is equal to 2x. 2x minus 4. That's good. So what's the coordinates of, okay, I can skip P, that's not a problem. But for F, if y is 0, it gives me 0 and 2. So that's F. So coordinates of F is 0 and 2. Now, how does it help me to find the area? Okay, let me just draw here a separate diagram. So with different points. So there is D, there is F, and there is, because there can be solved, this question can be solved in a few different ways, but it's just approach, it is minus 3 and minus 4, that is D. Minus 4 and minus 3, and that is minus 2, and that is C, minus 2 and negative 8, and that is F, which is what? 0 and 2. Okay. So you know what? The better way for me is this. You can actually just draw a rectangle around this and then find the areas inside those triangles. So see, I can have what? I can tell you this point is, what is that point? X coordinate is minus 4. So the length here will be, so it is 0 and minus 4. The length here will be 6. And then what about this coordinate? It is minus 4. Sorry, I wrote other way around, minus 4 and 0. It should be minus 4. It's on x-axis. Yes. It will be minus 4 and 0. Okay, so that will be minus 4 and 0. So you got that distance, or even that one is 0 and 2. Sorry. That one is 2 and 0. Am I right? Should we fix the coordinates of f on the top? We said 0 and 2. It must be 2 and 0. Yes. Sorry for that. It must be 2 and 0. Coordinates of f is 2 and 0. Now, if we come down, what do we see as the coordinate, as those other coordinates? Let's just figure them out quickly. So it's minus 4 and negative 8. So basically this makes that length is 8. So area of that rectangle, the yellow rectangle, is what? Area of rectangle is 8 times 6. 6 times 8, 48. Now I need to subtract the areas of small triangles so I can find the other shape. So this part is 3. Okay, that part is that's minus 8, so that is 5. And this part is 2, and it is another 2. So that's 4, 3, and that's 8. Now what are the areas? 1 over 2 times 3 times 6. That's 1 over 2 times 2 times 5. That's 1 over 2 times area of triangle, 1 over 2 times 4 times 8. So the area of triangles are, what are they? It is 9 plus, it is 5 plus, and then the last one is 16. So area of triangles add up to 30. So then the answer is, so the area of DCF area is 48 minus 30. It is 18 square units.
So,
yes.
So would we be able to use area rule?
You can use area rule, all is fine. You shouldn't lose any mark for that. So because it's actually a good idea, we already know the angle, isn't? So you can find distance DC and distance DF. So area rule can be used. All is fine with the area rule. Okay, let's write all. Area will be, let me just write, not the answer, 1 over 2 times DC times DF times sine alpha, which is already given. That should give the same answer, 18. All right, so that seems to be the last question for today. Please ask me through WhatsApp if you have any tricky questions. Sometimes it is.